As you can see my screen, right?
Yes, sir.
Yes.
Yes, sir.
Good. One second. Okay, there could be a problem with the yes, with the writing pen, I will make an adjustment later. Right now, I'll just use the mouse. Okay. So, welcome to the first part where I would only be introducing, and I'm going to take only a few slides just to give you why are we studying stem cell biology? Why should we study? It's just to build some motivation for that. So, one thing to build up on the problem and why we are studying it, we need to understand some things about about the world and human history itself, the way we are developing and so on. If you see the population, about 1750 until projected population rate is 2050. This is a very old map. I think we already reached 10 billion or something. Okay, we are somewhere around here. We already reached, which means the population would be much, much higher. And it is not the countries, the population of the developed countries or industrialized countries has not increased as much compared to the developing countries. And you know what is the problem with the population increase? And before that, why did the population increase so much? That's because of science and technology. That's because we no longer follow the natural selection. We are not under natural selection anymore. Natural selection is something the best will survive in the conditions and the others would die out. That means there is a natural way of somehow deleting or terminating the individuals that are not fit. Okay, that means if an insect or a frog has given or laid some 1,000 eggs, only about 10 of them or 100 of them would actually make it to adulthood. The rest of them would die. Sometimes none of them would survive at all. But in humans, we are no longer under natural selection. We have natural selection for us would have been any diseases at the childhood, something like viral or so on. But we have vaccination, we have made antibiotics, we have so many of those things. Therefore, not enough death rate was there. If you count the average lifespan of a human, it was about 42 years. That means majority of of them died very young, and only few have lived to a very old age. Okay, so even though there were people giving birth to 9, 10 births one single mother would have been given, majority of them died young. Only few of them were successful. But with the invention of vaccines, antibiotics, and other things, we are now out of natural selection. We have we have science and technology in many different facets, including building houses, more crops, agriculture, and all these things. We have no starvation, no. We have reduced the amount of death, but the amount of birth has remained as such. So what is happening because of it is that the population is increasing, and this is the problem because they are developing countries. They do not have enough food resources. They do not have a lot of. There will always be problems because of population. We'll get to that. So there is something called as carrying capacity. If you studied ecology in your +2, probably you must have heard of it. It's something like there is in a location there is a ability to produce food materials like plants, for example, and there is a limitation about how many would consume them, right? So every territory has a problem, has a limitation that is called carrying capacity. Earth also has a carrying capacity cumulatively. We originated in Africa, likelihood, and then we have almost occupied every continent that is available, and we colonized many of them, and we are now invading into the seas and airs, and even people are planning to go to Mars to make new places. So we have reached Earth has reached a carrying capacity. Humans are actually also terminating all the other species and occupying their space as well. That is all right. That is what is happening, of course. But the problems because of population will be in multifactorial. The sense that food is one thing. We have less fertile land, and whatever fertile land is there, it's decreasing because we are occupying more and we are building more buildings to live. And then we have water problems. Every person in the olden days, say when the civilization was not as good, say some 1,000 years or say some 4,000, 5,000 years old, how much water we will do it like this. How much water does a dog use in a daytime? In one day, per day, a dog might consume about 2 or 3 liters of water. And it would have passed off as urine, it would have evaporated and many things, whatever cycle it is there. Now take a typical human being. How many liters of water is being used? We use water for brushing our teeth. Although we brush, we use maybe at least 4 or 5 mugs of water to brush our teeth. To bathe, for bathing we use at least 20 liters of water, a bucket full. And drinking, we take up to 6 to 7. In the best case scenario, we drink 60 liters or something of water. And defecation, washing here, clothes, washing this, washing. You can count at least 100 liters per day per person. If not that big, count 60, 70 liters. Right? Where is the water going? And is the water just going out? We are putting soap in the water and we are draining it out. Right? So there will be, as more number of people are required, you spoil more water. You take from the underground, that is also going away. And then we are spoiling more water using soaps, chemicals, and other stuff, which is harmful to the rest of the species. That's one of the big problems. And space, of course, the more deforestation, more high population density, and these are some of the things that are the problems. But we are not going to address this as a part of this course. Food, water, space, there are problems. And also the health, because of pathogen associated, it could be lifestyle diseases or new diseases that are coming. And one of the other one is that I want to highlight here is the genetic disorders. The increase in population and the increase in genetic disorders is because humans are not as much under natural selection, right? So there are, what is a genetic disorder? A person who cannot lead a normal life with the available things, not the artificially in technology generated ones, science and technology generated ones. Just like an animal, the person cannot carry out a function. Like you can take it as sickle cell anemia. That person has advantages and many disadvantages too, just because of some genetic disorder. So the genetic disorder, the more and more we provide healthcare, the more and more people survive. When more and more people survive, even with deficiencies, they are likely to give birth to next generation, which may also carry the genetic disorder. I know being no mean by I do not mean that we shouldn't. What I mean is now we should do more and better ways of targeting these genetic disorders. That is so that the next generation wouldn't have inherited these genetic disorders. So we all know, I think in the molecular genetics class too, I might have discussed about what is evolution and how species actually happen. The fine tuning of species happens. A species is something what at least in the sexually reproducing organisms, it is the reproduction through sex, and if they are compatible, they all belong to one sex. When I say compatible, you mean that they should be able to mate and produce fertile progeny. So a lion and a lioness can mate and produce fertile progeny. A donkey and a donkey can do that. So can a zebra and a zebra can do, or a horse and a horse can do. If there is a mating between through artificial means or so, even if it is naturally occurring between a donkey and a horse, you get a mule. Mule is very strong with the features of both, good features of donkey and a horse, but the mule is sterile. So now donkey and horse cannot be considered a species just because they can give rise to a mule, but because they could not give rise to fertile offspring. So you should consider that as a non-species, or they are separate species. And every species gets fine-tuned by the nature. Fine-tuned in the sense the best will survive and those unfit will be removed or terminated, and that is done by natural forces. Why we say natural forces is anything other than what humans do is natural forces, right? So mate selection is also kind of natural source, self-selection or force of selection. And mate selection in humans is different. In animals, what happens? The strongest one is likely to get more and more reproductive opportunities, meaning that the offspring that come by will also inherit these genes for strength and this vigor from the male that is strong, that has won the most reproductive rights. What's with humans? Humans, mate selection is so different. It's not by natural selection, not as much at least. It is mostly by the men and women. I mean, with the modern way of civilization and organized society, there is a concept of marriage. One person marries another, a man and a female become a couple, and they lead together for a long time. If you look at our own closest ancestors or related cousins, like other apes, chimps or gorilla or bonobo, they don't follow anything like this. Especially in chimps and gorilla, The strongest male is likely the one which will get most reproductive rights with all the females. And maybe the other subordinates may get some opportunities, but not always. The leader gets the opportunities. I mean, there is no selection from the female side. The female does not get a chance to choose whom she wants to mate with in chimps or in gorilla. In humans, because we have a strong structure society, and we have a strata, and we have made a lot of rules, cultures, and many other things. So we have a concept of marriage. One person lives with other person, and they live together for a long time to make babies, make a family, and then raise them together. So there are two typically in animals you can call. One is called as tournament species, where there is always infighting among the males for the females. And the other one is called as pair bonding. There is a nice lecture by Professor Sapolsky. I'll try to post the link, and you might want to watch it to understand better. There is a whole course about evolution, behavior, and all this. He has a series that's freely available on YouTube by Professor Robert Sapolsky, and human behavior included as well. It will provide you a lot of insights, and I encourage you to have a look at that. So in humans, we are inbuilt. I think we are much more close or similar to what we should have been like chimps in terms of our mate selection as well, where the powerful kills or tames the other males, and the alpha male gets most of the reproductive rights. But that's not how things are. And we have social structure, marriage, concept of marriage, one person with one person. Every bird gets a worm like thing, and then they all raise children. So what I'm talking here is, if there are, sorry, I'll just talk about this one, and then we will probably see. What does a male want from a female? And what does a female want from a male? So the approach for the male is to have as many children as possible. Quantity, right? The male is designed in a way to have, especially if you're talking about chimps and gorilla. Assume there is, in humans, I think that is the default. It's an opinion. Could be wrong, but that's what I learned from so far, whatever I've seen and watched or read. Males is to increase the number of copies of its genome by increasing mating rights, so that you probably will have more number of offspring, thereby increasing the probability of his genes surviving longer, existing longer on the surface of Earth. The females, it is not about quantity, it is about quality. I want one or two very good offspring who can survive. It's no longer about probability, it's about certainty, right? Female would choose the best of the available mates. A male is supposedly built to have all the available mates. So both these strategies are correct. We are not talking about social morality and all those things. We are talking about the objectives, biological objectives in general. And the biological objectives is propagation or spatio-temporal propagation or existence of those genes. Right. So males is about increasing the number of offspring so that at least some will survive towards the end. And females is one or two, but very good quality. That is supposedly natural, but that's not how things happen. At the end, the marriage happens based on social norms, like are they rich enough? Are they popular enough? Are they powerful enough? Do they have everything? That is also nothing wrong, actually. I'm not talking if there is right or wrong. What I'm saying is not having a thorough look at the biology is may have contributed to a lot of genetic abnormalities. That is what I'm trying to say. So if you see the abnormalities, you will find many of those abnormalities. These are some just not necessarily genetic abnormalities, but there are so many of those. And they will happen. It is a pain for the parents. It's a pain for those who already have it. Firstly, because the rest of the species would look at them as weirdos or some kind of trying to belittle them, tease them, and all those things. And the parents have to be with them, try to um, somehow give them happiness. In doing so, many parents also feel a lot of burden, financial burden, to provide medical care. That's a problem. To protect their children, to console them psychologically, monetarily. You can think of many things. There are so many problems. And it's a problem for the whole family itself. You would not see much of those kinds of abnormalities in animals. But occasionally you might see some of these animals like this with an extra leg on the body of the cow. You would see abnormalities in domesticated animals. You would not see as many in the nature or wild. If in the wild something like this is born, it's very likely it would have been killed at a very young age by the predators or so. But if it is domesticated, then humans are taking care of it. So I hope what I'm trying to say is how something that is genetically not so great would be cleared off by natural selection in the wild, whereas in where humans influence or including the human species, you might find some of these abnormalities because we have come up with concepts like democracy, humanity, where we don't want any member of our species suffering. We don't want any of our member of our species struggle. We try to provide for them. If they cannot find their own food, we provide food to them. The family takes care. The society also sometimes takes care. That's humanity. So, evolution and humanity are kind of in conflict in that sense. Okay? I don't mean it in a bad sense. We are talking about the essence. So, if we talk, is it if you talk in several, if it also depends on how we look at stuff. If we look at the amount of pain the person who is suffering goes through and the amount of pain the parents goes through, it gives us a depressing look. But if we see it from those who are providing, right, it is morally very high and superior that they are able to do that for somebody who cannot repay. And that's something beautiful about the humanity. So the goal in life, I must have told you in the last course, or maybe not, to be happy and healthy also, as long as we live, and to live long. That's a human life or human objectives in general. If you take a talk about a frog or a fish, probably it would be to live as long as possible. It's simple. For humans, it is to be happy as long and live long, something like that. Health, to be healthy, to be able to reproduce, and to do something is what we all want to have. What we want, these are all for us luxury, right? It's all the animals would properly only look at to reproduce somehow. We have to, I mean, they can reproduce and exist longer if only they can um, they can survive. uh, the animals, that is the foundation for every animal, every plant, every organism. For humans we need more, and that is what is, we have many things. So we have problems in general. We will have problems with extra species conflicts, conflicts with other species, intra-species conflicts, that is conflicts between people, and defects in birth. I mean, as I showed some of the figures before, they're all defects from the birth. From the birth, there are also birth defects. There are reproductive defects where the children, or they, when they grow up, they might not be able to produce offspring. Hypoimmunity in some cases, less immunity, and in some cases autoimmunity. There is malnourishment. There is a lot of pollution. There are accidents, and there are also aesthetics. So people born with what they are, healthy and fine, are unhappy about what they look like, and they try to modify it. I don't find fault with that either. It is what they want, and if they can afford it without, then they should probably do it. So what I'm trying to imply here is, or my stance would be that the individual, as long as they're not causing problem to their existence, life, and they want to do small adjustments to how they would want to look like, I think it's an individual's choice. And when I'm talking about all this stuff in this particular course, and why I'm talking all these things, you might find it irrelevant, but it is highly relevant. If you're talking about stem cell biology and you would want to know some things about ethics, ethics is what should be done and what should not be done. It's about how to do it, and when you are doing it, what is the goal of what you're doing, right? And in stem cells, when you see, we will get to it. So I just want to put in some thoughts in your mind, and we will have a very good discussion about ethics where you will all have to contribute to it. And these are some of the points or directions. I'm not saying anything is right or anything is wrong. All I'm saying is these are some things that we can think of and should think of, or the way to think about it. Okay? We will get to it, and and then we will see something like this. So when there are accidents, like in this case, there are accidents or there are defects, there are problems with how they look. So a person here has lost a ring finger. Is it a big deal? Yes, it could be. Is it his left hand? Yes, maybe the wedding ring would have been a little bit of trouble. Is there any other problem? Not necessarily a problem for that person, because holding and other things we can actually manage and do it up. The problem is how many people would look at that finger and say, hey, what happened to your finger? Or they might even call names like fingerless person or something. Suppose assume that this is a guy and he is going to go and talk to a girl to impress her or something. And if she notices that this finger is missing, then she might not be impressed, or she might find it awkward, right? So there is a social consciousness about it. There is a social pressure building from what one person is supposed to have and don't have, or what one person is supposed not to have but has, right? Especially in the biological ones. We can have so many deformities in our eyes, limbs, or any of this, the way we walk, and people have a way of commenting on them. We get identified by our defects. We have this is a social problem. So the simplest one is to say, to put a cover like this. What is the value, or why do we do that? Is there any value to it at all? And why should that person do that? Just to avoid the social stigma, maybe to feel normal in his own mind, and to escape the attention of the others over that finger. But otherwise, there is no function to it. It cannot do any work, isn't it? So we need to have some way of addressing these things as well. While we in this course, when we are talking, many a times we will get to real life situations and conditions where we need to talk and try to become empathetic about those persons, and it should allow us to think in a much more matured way and respond or act accordingly, not be childish or inconsiderate of others feelings there. Okay. And if there are other ways of doing it where a leg is something very important for a person. Without leg, mobility is problematic. I mean, if you lose a limb, then what can one do is that you have a prosthetic leg, and then probably it will. So in the previous one, it is just there are two things for every solution, especially when we are talking about the bodily parts. One is the form. It should look like what it should look like. And the other one is function. Any solution should function as good as the original part. So the looks is the form, and the abilities is the function. In this case, it is serving the purpose of form, but it is non-functional. And what you're doing as a program, bioengineering, medical nanotechnology, they are all involved with trying to provide solutions to people with such defects where there is loss of form and loss of function, and you are supposed to provide a solution that eventually should have form and function. Out of form and function, what is the priority? The priority would be the function. Form later. Form is for others to look at. Function is for the body, right? If this person has a prosthetic, it will be useful to this individual. If the prosthetic looks exactly like the leg, then the social stigma would not be as much, right? So here you have a good, probably the best of the functions available, where she can control the robotic arm with her mind and to do some of the activities, and that way it is a good solution. But it doesn't look like an arm, isn't it? There are too many things, and probably every time it moves, it makes a lot of noises. So I hope you understood, when we are providing solution, we have to be considerate of form and function. And the best of the possibilities is to provide, if somebody has lost a hand or an arm, provide a new arm. That's the best solution. And to do that, what you're actually implying is that we should regenerate limbs and put the limb onto it, so that the limb looks like the limb. It functions as it should. And that's kind of goal of stem cell biology, right? To repair whatever is defective, to regenerate whatever is lost. And the foundation for this kind of medicine, the regenerative medicine, is stem cell biology. Your course here is fundamentals of stem cell biology. So we will discuss fundamentals of it. But then we will try to also go into a little more and try to understand it better, so that you will have good enough knowledge about stem cells, the functioning, and how it can be applied. So during this course, I would also want you to read more and think more upon what all problems can be solved. How can we improve the existing problems? That way, you will improve your critical thinking as well as your knowledge in stem cell biology. And stem cell biology is a mixture of cell biology and molecular biology. and then you apply it with nanotechnology and many other things. So we are in between. It's in the crossroad. It's stem cell biology becomes the junction of what all things can be possible in the future of medicine. So it is. I think I'll stop here, just to so that we don't have to, because you are all tired. I promise that I'll make it a small one. So if you have any questions, I would like to take here until this. Any questions? Okay, I'll stop the recording.